All right, let's continue example 11.4 that we were kind of in the mix of. So part B, we are looking at what is the torque on the meteor about the origin. And so we need to rewrite our momentum in terms of this velocity here. So let's go ahead and do that. So we have momentum is equal to our mass, which is given as 15 kilograms, times our new velocity, and that is going to be negative 2 kilometers per second, j hat, plus, actually minus 2, and this is now meters per second squared, j hat, times t. Okay, and so our linear or angular momentum here is going to have the same starting point. So we have r, which was, r bar, which was this here, 25 plus 25, and the I and the j hat. So we're going to go ahead, and put it into this form again. So taking that cross product. So we have I hat, and that's 25, and then 0 for our momentum. Okay. J hat, 25, and then for our momentum, it will be this whole term. So what I'm going to do is I'm just going to call this V sub y. Okay, so it'll be 15 times V sub y, and then K hat. Okay, so it'll be the same. We have I hat, and then times 0 and 0, J hat, 0, 0, and then K hat. So it's going to be in the K hat direction, times 25 times 15 V sub y minus 0. Okay, 25 times 0 is 0. And so we'll need to plug our V sub y back in, but we also need to take that derivative with respect to t. So let's go ahead and do that. So we've got dl dt is going to equal to k hat, and I'm going to just bring constants out front, 25 times 15, and then v sub y, so I have d dt of negative 2 kilometers per second, j hat, minus 2 meters per second squared, j hat, t. Okay, taking the derivative here, this will go to 0, and this will remain. So we get k hat, let me do this in my calculator real quick. We have 25 times 15 and times 2. So 750. And this is going to be in, is this in meters or kilometers? This is in meters. So we have meters per second squared. Yeah, we already took care of the J's here, so this doesn't need to be there. Okay. Okay, so this should be your torque. This is not the right units for torque, however. We forgot our kilograms here. And then 25, that was in kilometers, I believe. Yes. So this is times kilometers, kilograms. So this is a very odd unit, so you would move this to meters. So in 1 kilometer, we have 1,000 meters. So we should have 750 times 1,000 So that would be 1, 2, 3, 4, 5. 7.5 times 10 to the 5th meters squared per second squared kilograms. Okay? Alright, so let's go ahead and move on to angular momentum of a system of particles. And it's really very similar. It's just adding up all of the angular momentums of each individual particle. Okay, so that's what is shown here. So the total angular momentum of the system of particles is equal to the angular momentum of the first particle plus the angular momentum of the second, and so forth. Okay, so when we take that derivative, again, we'll get the total tau here, the total torque. Okay, so we can put this into an example here. So part A states determine the total angular momentum due to the 3 particles about the origin. Okay, so if we want to look at each of these individual, we will say this is 1, this is 2, and this is 3. Okay, they are already kind of labeled that way. So L1 is going to be R1 we're given force though. Let's see. R1 cross P1. So these R vectors are going to be the position of these particles. Okay, so, excuse me, we will have to determine where these particles are in space. Okay, so in this case, the first one, excuse me, I'm sorry, R1 should be, let's see, should be 1, or actually, should write it this way, -2 in the x direction, so it'll be I hat, and then plus 1 in the j hat direction. Okay, and our momentum is going to be P1, that will be M1 times V1, which is given as 4 j hat. And this is in meters per second. These are in meters. Okay, so then what we'll do is we'll take each of these and find their cross products. Okay, so let's go ahead and do that for this first one. So L1 is going to equal, we're going to have I hat, and that will be -2 and 0, and then j hat, we have 1, and M1 times 4, okay, and k hat, which have 0, so we'll have negative, M1 is 2 kilograms, so we have 2 times 2 times 4, so we have 8 times 2, which is going to be 16. Okay, and this is, let's see, this is going to be in K. Sorry, this looks kind of confusing. So I did, we have 1 times 0 and 0 times a constant. J hat, we have zeros again, and then k hat's the only one that has non-zero values. Okay, so this is in the k hat direction. So L1 is going to be -16 k hat, and it has units attached to it. Let's see, it's going to be kilograms meters squared per second. Does that look right? I believe it does. Okay. So this is L1. Okay. So we'll have to do that for each of the other ones. Oops, not part B. This is still part 1, or part A. Sorry. Okay, so L2 is going to be R2 cross P2. R2 is equal to 4, and this is I hat, plus we have 1 J hat. P2 is equal to M2, which is 4. So we're going to say 4 kilograms times our velocity, which is 5 meters per second I hat. Okay. Oops, sorry. So let's go ahead and do this. So we have L2, we have IJ, and we have 4 and 1. Then we have this term here, 4 times 5 is 20, so we have 20 in the I hat direction. 0, K hat, 0, and 0. So we get, again, all of these other ones are going to be zeros, right? So if we have I, we have 0 minus 0. For J hat, we'll have 0 minus 0, so we're left with K hat. And we have 0 minus 20. Okay, and so we have negative 20. And let's look at our units real quick. So this is going to be meters. Right, we have meters squared, right, kilogram meters squared per second in the K hat direction. Okay. Yep. All right. So then we have L3. So let's write down R3. This is in the negative direction here in the Y. So we have positive 2 and negative 2. So we have 2 I hat minus 2 J hat. And then our momentum is 1 times our velocity, 3 I hat. Times 3 I hat meters per second. Right? Yes. Okay. So now we'll do the same thing. L3, we have I hat, which is 2 and 3. We have J hat, which is negative 2 and 0, and then, oops, K hat, 0 and 0. And then again, we'll be just in the K hat direction. We'll have 0 minus a negative 6. Okay, so we have 6 K hat. And let's again look at our units. We should have kilograms, and this is again in meters. So we have meters squared per second. Okay, so those are all 3 of our angular momentums. So if we want to find our total angular momentum, we'll add them up. So we have, from 1, we have negative 16 K hat, negative 20 K hat, and positive 6 K hat. Okay, and we will finish this in the next video.